For topic two, we're going to look at the sum to products formulas. So we're going to take something that's written as a sum and we're going to convert it to a product. And what's nice about this is in some cases it allows you to solve an equation, okay? I should have mentioned this in the previous video and I don't think I did. I'm like 100% certain I didn't. Um, you may not really use these a whole lot now, okay? So don't be flipped out if you don't see these too much now. You're going to use them probably a bit more when you get into the calculus sequence. I'm trying to remember. I know I use some of this stuff in Calc 2. It's been a while though. Okay, so again, don't be super alarmed if you don't really see a ton of this in this class. It comes up in that calculus sequence later on, okay? Now we have the sum to product formulas. So if you have sine of alpha plus sine of beta, it can be written as 2 times sine of alpha plus beta divided by 2 times cosine of alpha minus beta divided by 2. And again, you don't have to memorize these, thank goodness. Okay, so just know how and when to use them. So know which formula to use and how to use it. Okay, now if you have sine of alpha minus sine of beta, that is equal to 2 times sine of alpha minus beta over 2 times cosine of alpha plus beta over 2. And then if we flip-flop and we switch over to cosine, if you have cosine of alpha plus cosine of beta, that equals 2 times cosine of alpha plus beta over 2 times alpha minus beta, or times cosine of alpha minus beta over 2. And then if you subtract your cosines, cosine alpha minus cosine beta, that equals negative 2 times sine of alpha plus beta over 2 times sine of alpha minus beta over 2. So again, thank your lucky stars you're not expected to memorize these because they're so similar, okay? And it's really hard to remember what goes where, okay? So you don't have to memorize these, but you do need to be able to pick which one to use and you need to be able to use it successfully, okay? So let's look at a couple of examples. So example 2, it says express each sum or difference as a product of sines or cosines, okay? So we have sine of 4 theta minus sine of 6 theta. So think of your 4 theta as alpha and your 6 theta as beta. Which of these formulas would we want to use? Well, we have a difference of sines. So we have sine alpha minus sine beta. So we're going to let that equal 2 times sine of alpha minus beta over 2 times cosine of alpha plus beta over 2. All right, so let's rewrite that. So we know this is going to equal 2 times sine of alpha minus beta over 2 times cosine of alpha plus beta over 2. So let's go ahead and fill in our alpha beta. We're going to take this nice and slow. So we get 2 times sine of alpha minus beta. So that's going to be 4 theta minus 6 theta over 2 times cosine of alpha plus beta. So that's going to be 4 theta plus 6 theta over 2. So we're just going to simplify a little bit. So we get 2 times sine of, well, 4 theta minus 6 theta is negative 2 theta, and that's still over 2. And then we're going to multiply by cosine of 4 theta plus 6 theta, which is 10 theta over 2. So that's 2 times sine of negative theta times cosine of 5 theta. Now, we're not quite done, but we're close, okay? We don't like having this negative argument for sine, okay? And please remember that sine is odd. So that means opposite inputs yield opposite outputs. So if I have f of negative theta, that equals negative f of theta. So I can take this negative right here and I can move it to the front. I'm not really moving it. I'm just acknowledging that if I have the opposite input, it gives me the opposite output, okay? So I'm going to rewrite this as negative 2 times sine of positive theta. Again, it's not like we're really like, it's not like we're factoring out that negative. We're just understanding the fact that sine is odd, which means this is true. So if we have the negative input, it gives us the negative output. Okay, so we can just kind of flip-flop it and bring that negative to the outside. Okay, so we get negative 2 times sine of theta times cosine of 5 theta, and that's it. There is nothing else that we can do with this. So this is our final answer. Okay, my hair's falling down. For part B, we have cosine of 29x, let's call 29x alpha, plus cosine of 11x, let's call 11x beta. So if we scroll up just a bit, we have cosine of alpha plus cosine of beta. What we want to use is 2 times cosine of alpha plus beta divided by 2 times cosine of alpha minus beta divided by 2. So that's the formula we're going to fill in. It's kind of messy, but I think you get the gist. All right, so let's start filling in. So we get 2 times cosine of alpha plus beta, so that's 29x plus 11x over 2, times cosine of alpha minus beta, so that's 29x minus 11x all over 2. So let's do a little simplifying. Excuse me. This is Diet Coke, I swear. Can you see? Diet Coke, just so people don't think I'm like throwing back a beer or something while I'm making your videos. Just Diet Coke to keep me going, y'all. Okay, so I get 2 times cosine, and then 29x plus 11x is 40x. So this argument is going to simplify to 40x over 2 for now. We'll simplify it further in the next step. And then the next argument, 29x minus 11x is what? 18x all over 2. So we simplify a little bit further and we get cosine of 20x times cosine of 9x. And that's it. There is not a darn thing else I can do, okay? Those arguments aren't the same, so I can't combine. I can't say it's cosine squared of anything, because for that to happen, the arguments would have to be the same. So that's it. That's as far as I can go, okay? Now let's look at example 3. So we have 2 different examples here. One I think you're going to kind of like, because we're using a product and we're going to write it as a sum, and then we can simplify it. And then the last one is an equation that we're going to solve. Okay, so for example 3, it just says short answer, and for part A, it says find the exact value of the following. So this is definitely a product. Okay, and we have a product of an alpha and a beta. So we have a product of sine of alpha times cosine of some other angle beta. So let's figure out which formula we need to use. So let's go up to our product to sum formulas. So if we look at our product to sum formulas, we had sine of alpha times cosine of beta. So we want to use this last one right here. So we have sine of alpha times cosine of beta equals 1/2 times sine of alpha plus beta plus sine of alpha minus beta. Okay? So let's write that out first. So this is going to equal 1/2 times sine of alpha plus beta plus sine of alpha minus beta. Okay, so let's fill everything in. So we get 1/2, and then I have sine of 195 degrees plus 75 degrees, because that's my alpha and that's my beta. And then I'm going to add to that sine of alpha minus beta, so 195 degrees minus 75 degrees. And this one's going to simplify a little bit more. So this one's going to be a bit more satisfying because we can actually evaluate this one. So let's keep going. We get 1/2 times sine of, well, let's see, 195 plus 75 is what, 270? And then 195 minus 75 is 120. And both of these values now, both of these angles are on the unit circle. Okay, so we can evaluate both of these. So if you don't have your unit circle sitting in front of you, pause the video and get your unit circle. Okay, now 270 degrees, I'm going to draw over here in part B for now. Okay, so if I were to draw an angle that is 270 degrees, it would be like this. Okay. This is 270 degrees. And if I had this point right here, whoo, Lord, if I was on the unit circle, the point on the unit circle would be 0, -1. So I can say that sine of 270 degrees is just -1. Okay? Now, 120 is a little different. Okay? So for 120, we would have something like this. So this would be our 120 degrees. And we have the point here of -1/2 comma √3/2. So sine of 120 degrees would be √3/2. And let's see if we can clean this up a little bit. So we do want to go ahead and distribute our 1/2. So that tells me I have -1/2 plus let's see, √3/4. I can leave it like that. I could clean it up and put it all over a common denominator. Let's do the common denominator. So I want to multiply top and bottom here by 2, which is going to make this -2 Well, let me clean that up. That's going to make this negative 2 plus root 3 all over 4. I like writing the negative second, so I think I'm going to change this and write it as root 3 minus 2 over 4, and that's it. You can't do anything else with that. That's as simple as that one's going to get, okay? But that's a lot nicer than the previous examples, okay? So this one is a little bit satisfying because when you rewrite this as a sum, you find out that you get these angles here and here that you can actually work with because they're on your unit circle. Okay, so let's look at part B. I do need to erase my beautiful unit circle or my angle from the unit circle. Okay. Now it says find all the solutions over 0 to 2 pi. So we're basically solving this equation. This should actually have a theta. That is a typo on Jillian's part. So this should say theta. That's a mistake on my part. Sorry about that. Okay. So we have sine of 2 theta plus sine of 4 theta equals 0. What in the heck do I do, right? Because I don't have the same argument, so I can't combine. I don't have like I can't combine like terms here. I don't have identities that give me something for sine of 2 theta or sine of 4 theta really, except for the well, I can kind of do some stuff, but I'm sort of stuck. There's not a lot I can do. And what's really cool about going from a sum to a product is that if we can set a product equal to 0, so if we can set a product equal to 0, we can use, let me erase my, this should be a theta. We can use the 0 product property. And that's really helpful when we're solving, okay? Now just don't forget that this x should actually be a theta. That was a typo on my part. Okay, so I have sine of 2 theta plus sine of 4 theta equals 0. So I have an alpha and I have a beta. Is there a way that I could go from a sum to a product? So let's see what we could do with that, okay? So let's look and see if we have a sum to a product formula. Okay, well, if I have a sum to a product, I might be able to do a little something with this. Okay, so we have sine of alpha plus sine of beta equals 2 times sine of alpha plus beta divided by 2 times cosine of alpha minus beta over 2. So let's look into using that formula. Okay, all right. So this equals 1/2 times, I already forgot it. I don't think I want the 1/2 here. I think I have a 2 that I need. Let me pull it up here. Okay, so we want to use this one right here. So we're going to get 2 times sine of alpha plus beta over 2 times cosine of alpha minus beta over 2. And just know that alpha is 2 theta, beta is 4 theta. Let's plug some stuff in and see how this one simplifies. Okay, so I get 2 times sine. Well, I'm going to get 2 theta plus 4 theta over 2 times cosine of 2 theta minus 4 theta over 2. So let's do some simplifying still. So let's see, 2 theta plus 4 theta is 6 theta. And then 2 theta minus 4 theta is negative 2 theta. Both of those are still over 2. So we get 2 times sine of 3 theta times cosine of negative theta. But remember, we don't like that negative argument. And you have to remember that cosine is even. So what that means is opposite inputs yield opposite outputs. So if I have a negative input, or not an opposite out, shoot, I'm tongue-tied really bad. So if we have opposite inputs, it yields equal outputs is what I should have said. So even though we have an opposite input, I have theta and negative theta, I still just get the regular old function back out. So the fact that cosine is even is really nice. This negative, we can just say, well, cosine of negative theta is just equal to cosine of positive theta because it is even and we know opposite inputs yield equal outputs for even functions. Okay, so excuse my tongue-tiedness earlier. Okay, so what we're going to do is we're going to rewrite this as 2 times sine of 3 theta times cosine of just positive theta, again, because cosine is even, and we're going to say all of this is equal to 0. So what we've done is we've taken a sum And we've rewritten it as a product and it equals 0. So now we can apply the zero product property. And what the zero product property allows me to do is it allows me to set each factor equal to 0. Okay. Now, before I do that, I'm going to divide both sides by 2. So 2 divided by 2 just becomes 1, and then 0 divided by 2 is just 0. So what I'm left with is sine of 3 theta times cosine of theta equals 0. So that tells me that sine of 3 theta is 0 and cosine of theta is 0. So we were able to really do a lot with this. It may not feel that powerful, but when we had this sum equal to 0, there wasn't really anything I could do. I can't factor it. My arguments aren't the same. I can't combine like terms. My arguments, again, aren't the same. There's not really any kind of wild identity. I mean, I've got the double angle formula here, but that's probably going to make it worse. But by taking this sum and writing it as a product, I can do a lot to solve because I can eventually get a simplified product that equals 0 where I can apply the zero product property. So let's think about this, okay? I'm going to start with cosine theta equals 0 first. So on the unit circle, what angles give us a cosine ratio of 0? Well, if we have theta equals pi over 2 and 3 pi over 2, so kind of imagine where those are. That would be pi over 2 is right here where we have the ordered pair 0, 1. 3 pi over 2 is down here where we have the ordered pair 0, -1. In both cases, cosine is 0. So at pi over 2 and 3 pi over 2, cosine of theta equals 0. Now, sine of 3 theta, we got to do a little more work, okay? We talked about this a few sections ago, okay? And we acknowledge that if we have sine of 3 theta, what's happening here is we're basically compressing our period. And so within that just normal cycle of 0 to 2 pi, we're going to get 3 full cycles of cosine. So let's see if, or not cosine, sine in this case. So let's see if we can kind of look at this on a graph. Do I have Desmos up? I don't think I have Desmos up, but we can go to Desmos. Don't do that. Let's do that. Okay, so let's just look at sine of x, okay? Okay, so this is sine of x, but let's go ahead and look from just 0 to 2 pi. So if we look from 0 to 2 pi, and let's increment by maybe pi over 4. And then on the y-axis, let's look like -2 to 2. That'll give us a full picture. Okay, so this is this is sine, okay? And we want to know really when does sine intersect the line y equals 0? Well, we have a point here, which is kind of going off the screen, and then we have a point here, and we have a point here kind of going off the screen. So we have these right here. It's not going to let me do that one. And then we have this one right here, okay? So we can see that in a normal cycle from 0 to 2 pi, including the 0, not including the 2 pi, we intersect basically twice, here and here. Remember, we're not including exactly 2 pi. So we basically get 2 solutions, okay? But what would happen if I change this from sine of just x to sine of 3x? Well, let me do a completely separate line so you can see them sort of side by side. Let's do sine of 3x. Well, what you can see, hopefully, is that from 0 to 2 pi, we don't get one cycle of sine. We get one cycle. So from here to here is one cycle. And then from here to here is another cycle. And then from here to here is a third cycle. So from 0 to 2 pi, sine is going to cycle 3 full times. That means it's going to intersect the line y equals 0 in 3 cycles. So we're going to get 1, 2, 3, 4, 5, 6 solutions, okay? So let's go ahead and just look at that line y equals 0 again. Put 0, don't put O. So it's kind of hard to see, but it's this blue line right here. So we can see that at 0, 0, we have a solution. At pi over 3, we have a solution. At 2 pi over 3, we have a solution. At pi, we have a solution. At 4 pi over 3, and then again at 5 pi over 3. We intersect that line, y equals 0. So when we go back to our worksheet and we go to solve this, we need to remember that if we have 3 theta, that's going to give us 3 full cycles of cosine from 0 to 2 pi. And each cycle intersects that line twice. So that's essentially going to give us 2 solutions times 3 or 6 solutions, okay? So keep that in mind. Now, what we do is we do a u substitution. We say, okay, we're going to let u equal 3 theta. So then what we're solving initially is sine of u equals 0. And so then we ask ourselves, well, where does sine equal 0? So if we're on the unit circle, we have the ordered pair 1, 0, and then we have the ordered pair -1, 0. So right here, sine is equal to 0 at 0 radians and at pi radians. So when we solve the equation sine of u equals 0, we know that u is 0 radians and pi radians. But let's go ahead and add a couple of cycles here, because remember, we're not going to get 1 cycle of sine, we're going to get 3 full cycles of sine. So we want to do u plus 2 pi. So 0 plus 2 pi is 2 pi. Pi plus 2 pi is 3 pi. And then if we do another cycle, it would be u plus 4 pi. So 0 plus 4 pi is 4 pi. Pi plus 4 pi is 5 pi. Okay, so those are our values for u, but we're not done because remember, we let u equal 3 theta. Okay, so we're going to say, okay, 3 theta equals 0, 3 theta equals pi, 3 theta equals 2 pi, 3 theta equals 3 pi, 3 theta equals 4 pi, and 3 theta equals 5 pi. Okay, now we have to solve all of these for theta, which means for all of these we need to divide by 3. So I get theta equals 0 divided by 3 is just 0. Theta equals pi over 3. Theta equals 2 pi over 3. Theta equals 3 pi over 3, which is really just going to simplify to pi. And then we get theta equals 4 pi over 3. And finally, theta equals 5 pi over 3. If you double check, all of these are going to be less than 2 pi. Don't forget the 2 solutions you had here. So finally, we would say, well, theta equals 0, pi over 3, pi over 2. I got the pi over 2 up here where cosine is equal to 0. 2 pi over 3. Let's see where I'm at. Pi, 4 pi over 3, 3 pi over 2. Again, that one came from up here. And finally, 5 pi over 3. So those were all of the solutions to this initial equation of sine of 2 theta plus sine of 4 theta equals 0. Okay, so we had to convert the sum to a product, and then we were able to apply the zero product property, and that gave us the ability to solve this equation. Okay, so kind of messy, a little bit involved for sure. You get a whole bunch of solutions, but not the worst problem ever. Okay, so there you have it. This video was all about how to use the sum to product and product to sum formulas. Hopefully you found this super useful. Just don't forget, we don't want those negative arguments, so keep in mind sine and cosine are either even or odd. Okay, in fact, sine is odd, cosine is even. All right.